Why do some programs become extremely slow when data gets bigger? Today I will show you exactly why, using just one word as an example, banana. That will be our string. This code compares substrings of length m starting at different positions. We are going to visualize how much work it actually does. We'll use banana as the string, and the length is 6, and the substring size is m, which is equal to 2. In coding, if we could name the positions of our letters, this one will be on position 0, 1, 2, 3, 4, 5. If we are to consider substrings of length 2, we have, when I is equal to 0, we have BA, and when I is equal to 1, we have NA. So we have NA for I is equal to 2, NA, and for I is equal to 3, we have AN, and for I is equal to 4, we have NA. The comparisons when I is equal to 0 for BA are AN, which is we have AN, this one, AN, NA, AN, and NA, which are 4 comparisons. And for I equals to 1, we have AN. Sorry, we are comparing AN with NA, AN, and NA, which are 3 comparisons. For I, which is equal to 2, we are comparing NA with AN and NA. And for I equals to 3, we are comparing AN with NA. So you can actually see that the number of comparisons for BA is 4, for AN is 3, and for NA is 2, and for AN is 1, for NA is 0. So in total, we have 4 plus 3 plus 2 plus 1 plus 0 comparisons. This sum can be shortened, can be found using the sum of n terms, which says n by n minus 1 over 2 if we are starting from 0. So this one, we have 5 terms, so we have 5 by 5 minus 1 over 2, which is equal to 5 by 2, which is equal to 10. So you can actually see that this one is of order, this sum is of order n squared. Why? Because we have n times n. So the highest polynomial power there is n squared. That's the order of this one. So usually it's return order n squared. But we are not done. Each comparison is just one step. So lastly, our algorithm will compare BA versus AN and B versus A and A versus N, which are two comparisons. Each comparison checks M character. So if you are to generalize the number of comparisons, is approximately n squared, and the work per comparison is equal to M. Total work is equal to n squared by M. So total work becomes of order n squared M. This is why algorithms become slow. As n grows, comparison grows like n squared, and 1 cos M. That's explosive growth. So remember this. The algorithm compares every pair of substrings, and each comparison checks M characters. That's why the complexity is O n squared M. And that's why we need better algorithms.